All right, welcome back. I know at the end of the video you're like, no, don't stop yet. I don't know how to do the complicated ones. So let's do the complicated ones. We talked about how to balance redox reactions. We listed all the steps that didn't apply to the very simple example that we were using, but here it's going to apply. We're going to use all of our steps here. And so we're going to balance a relatively complicated looking redox reaction. We're going to start with a dichromate ion, Cr2O7 minus. And we're going to add that to C2H5OH liquid. This guy's aqueous. And we're going to go to chromium 3 plus and some CO2 gas. So you see we actually have three different phases here. We've got the aqueous phase, we've got the liquid phase, we've got the gaseous phase. Okay, so how's that all going to work? And right, we've got chromiums, we've got oxygens, but if you look at this weird reaction, we have hydrogen on the left, but we have absolutely no hydrogen on the right. And you're like, we can't possibly balance that reaction because there's no hydrogen on the right. Remember, in redox reactions, we do end up adding water and we do end up adding hydrogen. So we can always balance oxygen and hydrogen even if they don't appear on both sides. So never be worried about that in a redox reaction. If you have a regular reaction, worry if you don't have the same elements on both sides. But for redox reactions, the way we do it, we can add oxygen, we can add hydrogen, so you don't need to worry about that. So this one does look really, really complicated. And looking at this one, you're like, I don't know how to figure out who's oxidized, who's reduced, and things like that. But it turns out in the process of balancing this, just by following a very rigid set of rules, all that will come to us all by itself. We don't need to actually know what we're doing. We can actually just follow the rules. And it's good to know what the rules are doing, but you can actually just follow the rules and not know what you're doing. And the rules at the end will tell you, oh, here's what you're doing. So it's really cool. First thing we're going to do is we're going to break into two half reactions. That's our first rule. And we're not going to break chromium into carbon dioxide. That doesn't work because we do need all other elements to have some balance on either side, right? So we need chromium to balance with chromium. And so our first half reaction is just going to be Cr2O72 minus goes to Cr3 plus. And again, as we're doing this part, we're a little callous and loose about writing our phases, and that's perfectly fine. The other one, C2H5OH, goes to CO2. All right, so how are we going to balance these two half reactions? We're going to go through our rules. We're going to make sure that everything's balanced the way it's supposed to. First rule is we have to balance all atoms other than hydrogen and oxygen. So we're looking at that first half reaction. We've got two chromiums on the left, only one on the right. So I'm going to go ahead and put a 2 here to make sure that I've got 2 chromiums on the right. Here we've got C2H5. We don't worry about the H, we don't worry about the O, we don't worry about the H, but C2 on the left, so we need 2 CO2s on the right. All right, so there's our first step. What's our next step? We're going to balance oxygen using water. So that's our second step, balance oxygen using water. If you need these steps written out, they're in the last video. I'm not going to write them out all again. I'm just going to say them out loud. So balance oxygen using water. I have 7 oxygens over here, so I need to balance using 7 waters on this side. On the lower one, I need to do a little calculation. I've got 1 oxygen on the left. I've got how many oxygens on the right? 4. Why? Because I got that 2 in front of the CO2. Don't forget your coefficients there. Okay, so I've got 4 on the right. So what do I need to do? I need to make sure I've got 3 more on the left here. So I have 3 H2O on the left over there. All right, so what's next? I'm going to balance hydrogen using H+. It has to be in this order. Oxygen first, then hydrogen. Hydrogen using H+. Well, the only place I have hydrogen here is in my 7 waters, and so I'm going to get a 14H+. And it's quite common that in balancing complex redox reactions, we get things coefficients of 14, 28, 36. Happens all the time. You know, you shouldn't get 742, but don't worry if you're getting some relatively large coefficients, especially for the hydrogen. It's really, really common. On the bottom, what do we got to do? We got to count. We've got 6 hydrogens here. We've got 5 hydrogens here. We've got 1 over here. So 6 plus 6 is 12. And so we're going to put 12 H pluses on this side. And you'll notice that as I'm doing this, I'm not writing a new line each time. That is so incredibly tedious. I'm just adding things to the left and the right, kind of expanding in both directions. So I start with my half reactions in the middle of the page. I just expand on both sides as I go. Much, much easier. Maybe you're slightly more likely to make a mistake, but you're also not copying and copying and copying. Every time you copy, you're likely to make a mistake. All right, the next thing, we've got our H's balanced, we've got our oxygen balanced, we've got all of our regular atoms balanced. Next thing we need to do is balance our charge. And remember, charge is not oxidation state. Charge is literally just looking at the superscripts of each of them. I've got 14 times plus 1, so I'm going to have a positive 14. I've got 1 times a minus 2, so that's going to be, I've got a 12 plus on the left. On the right, I've got a 3 plus, and I've got 2 of those, so I've got a plus 6. And how do I make plus 12 is equal to plus 6? By adding something negative. By adding something negative, I've got to add 6 electrons over here. So I've got to add 6 electrons on the left so that my charges balance out. So if I add, plus a minus 6, I now have 6 plus equals 6 plus. On the bottom, I don't have any charges anywhere except for on the H plus, so that makes it really, really easy. I need to balance those H pluses with some minuses. I've got a 0 total charge on the left. I'm going to need a 0 total charge on the right. I'm going to do that by balancing with 12 electrons. All right, so now we've got our first reaction, 6 electrons, 14 hydrogens, dichromate to the chromium 3 ion and water. The second reaction, 3 waters, our ethanol going to CO2 and 12 hydrogens and 12 electrons. Remember, we next have to make sure that we have the correct number of electrons, that if somebody's giving away 12 electrons, there's somebody accepting 12 electrons. And so very, very similar to our previous example, we're going to end up multiplying everything here times 2. Why? We have 12 electrons in the second one. If I multiply the first one, I get 12 electrons in the first one. So I'm balancing electrons in this step. Then I need to write everything out in one big long thing and cancel stuff as I go. So I have to remember to multiply everything in the first one by 2. Some people like to go through and write the 12 here. But my computer's not going to let me. 12, 28, 2, 4, 14. You can certainly do that. Cross that out so you don't do it twice. You can certainly do that. Like I said, I generally don't do that step. I just do it in my head as I'm doing it. Either way is fine. Okay, so I've got 12 electrons plus 14 hydrogens plus 2 dichromate ions plus 3 waters plus C2H5OH ethanol goes to, I ran out of space. Really common. Running out of space, really, really common. I'm just going to put that on the next line. I've got 4 chromium 3 plus. I've got 14 waters. I've got 2 CO2s. I've got 12 H pluses. And I've got 12 electrons. What always, 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 always has to happen, I put a plus on my electron. What always, 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 always has to happen is, it's not letting me erase. I don't know why. Okay, is your electrons have to balance out. If you've got 12 electrons on the right, you better darn well have 12 electrons on the left. So those are going to cancel out. What else is going to cancel out? I just move along. It's mostly going to be the hydrogens, the waters, and the electrons that cancel. Okay, I've got 14 hydrogens on the left. I've got 12 hydrogens on the right. So if I subtract 12 from either side, I end up with 2 hydrogens left over there. I've got 3 waters on the left. I've got 14 waters on the right. If I subtract 3 from both sides, I end up with 11 waters over there. And that's all that's going to cancel. Nothing else is going to cancel. Then I summarize all of this in the final one where I'm now paying attention to phases and all those other things. And so doesn't really matter to me what order you write things in. Some people really like to start with the main elements, the dichromate, the ethanol, and then they put the hydrogens and waters and things like that. I'm okay if you just kind of write it in the order it appears, and it doesn't really matter to me as long as you've got the right elements on the right sides with the right numbers in front of them. All right, so we've got 2H plus aqueous plus 2 dichromates aqueous plus C2H5OH. That was a liquid. Goes to, I ran out of space again, a little smaller, I probably could have done it. 4 Cr3 plus 11 waters plus 2 CO2s, and those was gas, liquid, and aqueous. All right, so that is our overall balanced chemical reaction for that particular redox reaction. Very complicated in terms of the numbers, right? Just lots of numbers to keep track of, but simple in that it's rules, very strict rules followed in order will get you there every time. All right. So you'll notice in that last one, and I'm going to go back just so you can notice, is that our answer had H plus in it. Well, where is that H plus coming from? I mean, do we just like pick it out of the sky? Bing, H plus, here you go. Well, it turns out most electrochemistry is done, and I have no idea why I can't erase anymore. I have something that has an eraser on it, but it's not letting me erase. No erasing. All right, most things, when we run electrochemical reactions, we either choose to run them in acidic solution by adding an acid, like we might run this in hydrochloric acid, or a car battery is run in sulfuric acid, H2SO4. And so we might choose to run it in an acid, but we can also choose to run it in a basic solution. And one of the experiments that we do actually shows that you actually get different chemistry sometimes when you go into acidic solution or you go into basic solution. I'm not asking you to predict that, like, hey, in basic solution we're going to get this chemistry, in acidic solution we're going to get this chemistry. But I am going to ask you to be able to balance electrochemical or oxidation reduction reactions in both acidic and basic solution. The lovely thing is, to balance I keep saying electrochemistry because we're getting to that next. To balance redox reactions in basic solution, the first step is to balance that redox reaction in acidic solution. You can go on the internet and you'll find people who do it otherwise. Great, good for them. I'm happy for them. But I'm like, hey, if I don't have to memorize a new entire way of doing this balancing, I'm all for that. So the method I use is you balance the thing in acidic solution exactly the same. So literally, if I said, hey, let's balance this previous one in basic solution, we would have done all this exact same work. We just wouldn't have circled this as our answer because there's one more step we would have added. Okay? I like that because it makes it like, hey, there's not much new. Okay, so I'm going to just do this example first, and then I will tell you what the step that we add is, as opposed to telling you the step first. All right, so what we're going to do is we're going to balance some MnO4 minus, and that's going to be an aqueous solution, and some ClO3 minus, and that's also aqueous. And we're going to balance that to ClO4 minus aqueous, and Mn2 plus aqueous. But we want to do this in basic solution. But the first step is balance in acidic, which gives us a great chance to practice doing everything again. I'm going to go a little faster in this one than I did last time, not trying to say as much what I'm doing, but definitely still talking through. Okay, we write our two half reactions, right? I know that it's got to be manganese on either side, otherwise life wouldn't work. I know it's got to be chloride on either side, otherwise life wouldn't work. You don't have to worry about hydrogen and oxygen, but worry about everybody else. So what do? First thing, we're going to balance things other than hydrogen and oxygen. Done on this step, no need to work that. Balance my oxygens using water. Balance my hydrogens using H+. Balance my charge using electrons. This one I'll be a little more clear on. I've got 8 plus a minus 1 is equal to 2. So I've got 7 is equal to 2. How am I going to do that? I'm going to do 5 electrons over here. So I've got 5 electrons on that side. Yeah. And then on the bottom one, what am I going to do? I've got to balance my charge. I've got a minus 1 over here. I've got minus 1 plus, it's just not letting me delete, I don't know why, plus 2, right? So I've got minus 1 is equal to minus 1 plus 2. I need to put a couple electrons over here to balance that guy out. Okay, that's how I get minus 1 is equal to minus 1. All right, electrons, always on opposite sides. Remember, they're always going to have to cancel. If you find you balance something, you get electrons both on the left or you get electrons both on the right, you did something wrong. It's a very clear indication that you need to do something different. All right, our next thing, we need to balance these to make sure our electrons are balanced. Right, 5 and 2, you're essentially finding, what is it, the lowest common denominator. So I'm going to multiply this first guy by 2. I'm going to multiply this second guy by 5. And that gets me 10 electrons in each half reaction. I'm going to go ahead and add everything up. I've got 10 electrons plus 16 H pluses plus 2 MnO4 minus plus 5 H2O plus 5 ClO3 minus. And I'm going to turn that into my next line, which is 2 Mn2 plus 8 H2O plus 5 ClO4 minus plus 2 times 5 is 10 H plus 10 E minus. Lots to do, right? But there it is. Everything added up together. Then we cancel. Electrons better darn well cancel, otherwise we did something wrong. I've got 10 hydrogens on the right, 16 on the left. So I can just go ahead and put a 6 here. I've got water, 5 on the left. 8 minus 5 is 3. And there is my balanced chemical reaction, right? The next thing I'm going to do is write this all out a little more neatly. I'm going to be doing another step, so I'm not going to write my phases quite yet. I'm going to do 6H plus 2 MnO4 minus plus 5 ClO3 minus goes to 2 Mn2 plus 3 H2O plus 5 ClO4 minus. There we go. If I had put phases on that, that would be my answer for balancing an acidic solution. I'd be done. But I'm balancing in basic solution, and so now I do one more step. And my next step for basic, here's what you want to do, is add 1 OH minus to both sides for every H plus present. Right? Just like in math, if I have an equation where A is equal to B, and I add 3 to both sides, I get A plus 3 equals B plus 3. That's true. Same here. I'm going to keep the chemistry, but I'm going to add something to both sides to make it look different, and it's still going to be true. Okay, so I'm going to add 1 OH to both sides for every H plus present. I've got 6 H pluses present, so I'm going to add 6 OH minuses to both sides. Really common for people to just add it to one side and then forget to add it to the other side. You're adding it to both sides. 6 OH on the first one, 6 OH on the second half. What happens when H plus and OH get together? Hopefully you thought water, right? Because that's what happens. These two actually combine to make 6 waters. Okay, so now I've got 6 waters on the left, everything else, and I've got 6 hydroxides on the right. You will often have to do another canceling step here because you created water. You might have to cancel some water. And I've got 3 waters over here. So I'm going to cancel out those 3 waters. And now I can write my final balanced chemical reaction. Yes, these things take a while. I've got 3 H2O liquid plus 2 MnO4 minus aqueous. Wait, what happened to those OHs and H pluses? Remember, they reacted to make the water. They're not there anymore. Plus 5 ClO3 minus aqueous goes to 2 Mn2 plus aqueous plus 5 ClO4 minus aqueous plus 6 OH minus aqueous. And that is this redox reaction balanced in a basic solution. Do the acidic solution, add OH to both sides, cancel out some waters, and then you're done. They're not difficult, but they are a bit tedious. Totally get the tedious part. All right, check in. Your turn. You're going to try to balance some electrochemical redox reactions here. Okay. How many H plus ions are present in the balanced chemical reaction in acidic solution for this unbalanced redox reaction? Remember, this is going to take you a few minutes. This isn't just a bing. Okay, so you're going to go. You're going to do all the different steps in here. Figure out the answer. Tell me how many H pluses are in your final balanced reaction. Go. Here we go. I minus goes to I3 minus. Not I minus 3, but I3. 3 iodines together with a -1 charge. And ClO minus goes to Cl minus. First, balance non hydrogen and oxygen. So we've got 3 iodines balancing with 3 iodines. Then we're going to balance water to get our oxygens balanced. Nothing in the first one because there's no oxygens. Then we're going to balance H plus. Right, then we're going to balance charge. I've got a -3 over here, and I've got a -1 over here. So I need 2 electrons there. I've got a +2 here, and a -1 equals a -1. So I've got to put what? 2 electrons in this side. And very nice of me, you didn't have to multiply electrons out for this one at all. And so we've just got what we have here. Our electrons are balanced, so we put all those together. 3i minus plus 2e minus plus 2h plus ClO minus goes to I3 minus plus 2e minus plus Cl minus plus H2O. And we cancel out our electrons. There's no hydrogens to cancel out. There's no oxygens to cancel out or waters to cancel out. So I end up saying, hey, I've got a coefficient of 2 in front of that, which is what the question was answering. What we normally do is we normally then take this, write it out with phases properly and nice and pretty, so it doesn't have all the canceled species in it. But in this case, we just wanted the answer C. All right, one more for you to try. We're going to take this one and say how many hydroxide ions are present in the balanced chemical reaction in basic solution for this unbalanced redox reaction. Go! TikTok. No, not that kind of TikTok. I've actually never in my entire life logged on to TikTok. I have no idea. I mean, I've heard of it, but anyway. All right. How are we going to do this one? NO2 minus goes to NH3. We've got aluminum going to AlO2 minus. Okay, our non-hydrogen oxygen, they're already balanced. We're going to balance oxygen. We've got 2 waters. We've got 2 waters. We're going to balance hydrogen. We've got, what is that? 4 plus 3 is 7H plus. We've got just 4H plus over here. We're going to go ahead and balance. Why are we using H plus? Because the way I do it, and I really like this way, is balance everything just the same, and then we do a step at the end. So we're balancing acidic, and then we turn it into basic. All right, 4H plus there. We've got to check our charges. We've got, let's see, on the top, we've got a +6 on the left. We've got nothing on the right. So what do we need? We need 6 electrons over here. Let me make sure I'm getting that right. And then on the bottom, we've got a 0 on the left, and we've got a, did I do that right? I feel like I did something wrong. Let me just double check real quick. I've got my 2 waters. This is really easy to do, right? AlO2, I should only have 2 waters, right? Yeah, 2 waters. Okay, there we go. I was doing things fine. It's just I wasn't looking at the right line. Okay, and then I've got a +3 on this side, right? +4 -1, and so I need 3 electrons to balance that out. I've got 6 electrons on one, 3 electrons on the other. I'm going to go ahead and multiply this guy times 2, add them all together. I've got 6e minus plus 7h plus NO2 plus 2 times 2, 4H2O plus 2Al goes to NH3 plus 2H2O plus 2AlO2 minus plus 8H plus 6E minus. Ding, da, ding, da, ding. Okay, we have to cross out things that need crossing out. I've got 7 H pluses on the left, 8 on the right, so I just end up with 1 there. I've got 4 waters on the left, 2 waters on the right, so I just end up with 2 there. So when I do this one, let me write this out a little neatlier. Neatlier? Well, that's awful. 2H2O plus 2Al goes to NH3 plus 2AlO2 minus plus H plus. Remember what we do when we're balancing in basic solution is we add 1 OH to either side. These two combine to make water. That will cancel one of the waters here. And so we would then write that out neatly if that was our goal. Our goal here was just to know how many hydroxides, which is just a nice little 1 over here. So our answer is B. We have 1 hydroxide on both sides. All right, so that's your practice with balancing redox reactions. Very much like everything else in this class, the way you're going to know how to do this well is by practicing. So you're going to want to go out, you're going to find some more redox reactions either in your book or on the internet. You're going to practice balancing them using the steps that I gave you and see if you get the right answers. Thanks so much for listening. Have a wonderful day.